Problem number 3. We are given some function, and first thing, we want to find the first non-zero numbers and the general term for the Taylor series for f about x equals 0. Well, um, let's do it the hard way and then the easy way. So the hard way is if you know nothing about e to the x. So we have f of x equals 6 e to the negative x over 3, and f prime of x. Taking the derivative, we're going to get negative 6 over 3 e to the negative x over 3. And the second derivative, we're going to get 6 over 3 squared e to the negative x over 3. And the third derivative, we're going to get negative 6 over 3 cubed e to the negative x over 3. And we want to make a Taylor series around x equals 0, so we need to find these values. So this at 0, we're going to get 6, negative 6 over 3, 6 over 3 squared, and negative 6 over 3 cubed. So my Taylor series then is going to be 6 minus 6/3 x plus 6 over 3 squared over 2 factorial x squared minus 6 over 3 cubed x cubed over 3 factorial. And I intentionally didn't simplify those 3 squareds, 3 cubes, these terms right, or these numbers right here. I'm intentionally not simplifying them just so that when I do the general term, it makes it a little bit clearer what's going on. So writing this as the general term, we're going to get the sum. Well, we've got 6 times negative, or start at n equals 0 and go to infinity. So negative 1 to the n times x over 3 to the n, all divided by n factorial. And you can check to see if that works. And it does work. So, well, I said this is the hard way. What you also could have done, it said, well, I know if you know e to the x, and this is one you might want to just put in your head. You know that e to the x is the sum from n equals 0 to infinity of x to the n over n factorial. So e to the negative x over 3 is just going to be inserting negative x over 3 into this. So we get negative x over 3 to the n over n factorial. And then taking out the negative, we get, which equals negative 1 to the n times x over 3 to the n over n factorial. Oh, sorry. And we want it to be, we want that 6 in front. So 6 in front, 6 in front, or I could just put the 6 right there. And we get the exact same thing that we got before. So one is regenerating everything. That was the first method. The second is using e to the x, what we know about e to the x, and just doing a transformation from that. So that's the first. That's the answer to part number 1, or part A, which we can't really read anymore. And then it says, so let's let some function g, let g be the integral of f of t. Find the first 4 non-zero terms and the general term for the Taylor series for g about x equals 0. So what we want to do is we're integrating. So this is g of x, and we're going to integrate the terms. So writing out the terms, we have 6 minus 6 over 3x plus, and we're talking about in terms of t. So 6 over 3t plus 6 over 3 squared t squared 2 factorial minus 6 over 3 cubed times t cubed. And this goes on, but we're just looking for the first 4 non-zero terms. So we stop here. dt. Okay, so now we do the integration. So we get 6t minus 6 over 3 t squared over 2 plus 6 over 3 squared t squared 2 factorial. Oh, sorry, this should be t cubed. And then we have to divide by this 3 from here. So, and then minus 6 over 3 cubed t to the 4th over 4 times 3 factorial. And again, this 4 is coming from that integration and needing to cancel it off. Okay, well, if it's not totally clear what just happened, the bottom. Let's look at this one, for example. We had 2 factorial. Now it's 3 times 2 factorial. So this is 3 factorial. We had 3 factorial, and now it's 4 times 3 factorial. So that's 4 factorial. So if we wanted to write the general, if we want to, we're asked to. So to write the general, we're going to get the sum from n equals 0. Let's go from n equals 1 to infinity. And I'm going starting with 1 since my first term is not just a constant. So what do we get? We have 6 times t to the n over n factorial times, and then we have to, so the n factorial, now we just need to take care of, these 3's and the 3 squared and the 3 cubed. Well, those are all just one degree less, so times 3 to the n minus 1. And lastly, we need to take care of the negative sign because it's alternating. So since I'm starting with n equals 1, and since we start with a positive, we'll multiply this by -1 to the n plus 1. So there we go. Now, this we could have written this starting at 0. It doesn't matter. Had we written it as starting at 0, it would have been -1 just to the n times 6 times t to the n plus 1 over n plus 1 factorial times 3 to the n. It does the same thing. It operates completely the same way. And if you're dubious on that, just try it out yourself. Okay, so that's B. We're done with B. Now let's look at the last question. And the last question, I think, potentially could look the hardest, but it's actually really the easiest question to do. So what they give us is they give us that h of x. I can't even read that well. Yeah, h of x equals k times f prime of a of x, and they want and they're saying what must be true, or not what must be true, but find the values of a and k such that this function equals 1 plus x squared 2 factorial plus which is interesting. That's e to the x. Cool. Well, okay. Anyway, so to do this, what do we need? Well, we know that f of x equals 6 times e to the negative x over 3. So what I recommend doing, let's try to write a couple terms of h of x. So first, let's kind of find that. So we need to find the derivative. F prime of x equals -6 over 3 e to the negative x over 3. So f prime of a of x is going to equal -6 over 3 e to the negative ax over 3. And putting a k, multiplying it by k, just multiplies everything by k. Okay, so the first, so here we can very quickly find one of our variables. So since we're trying to center it around x equals 0, we know that when we evaluate this function for 1, it should equal our first term. This is h of 1. And we also know that h of 1 equals k times f prime of a times 1. So we put 1 into here. So it equals -6k over 3 e to the, oh, sorry. This is h of 0 because it's centered around 0. H of 0. We're putting 0 in for x. My apologies. So e to the minus a times 0 over 3. Well, this is all 0, so it's just e to the 0, which is 1. So we get left with -6/3 k equals, well, it needs to equal that value, so it equals 1. So from that, we get that k equals -1/2. That's the first of two variables. Now we need to find a value. Well, let's go one derivative down. What do I mean by that? Well, this coefficient here, it's not written there, but it's a 1. So we know that from here, we know that h prime of 0 equals 1. So let's take the derivative, h prime of x. Taking the derivative, we have -6k over 3 times e to the negative ax over 3 times, well, times the derivative of the inner function, which is negative a over 3. And at 0, so h prime of 0, at 0, this just equals -6 k over 3. At 0, this is e to the 0, which is just 1. So that kind of, well, it doesn't kind of, it goes away. So negative a over 3. And we know that this equals 1 from up here. And we also remember we know k already. K is -1/2. So this gets us to, well, that's -2. So -2 times -1/2 times negative a over 3 equals 1. And with just a little bit of algebra, we get that a equals -3. So I found those two values. That's it. So that's the question number 3.